In this video, we're going to learn how to classify triangles as equilateral, isosceles, or scalene using the Pythagorean theorem. Remember that an equilateral triangle has three equal sides. You'll either be able to see them directly on a grid, or you'll see the way that they're marked. They'll be marked as having three equal sides. An isosceles triangle is a triangle with two equal sides. I can actually count along the grid lines here and measure this and know that it has two equal sides. So that means it's isosceles. In a scalene triangle, it will have three different sides. Like here, this measures 3, this measures 4, and of course, this measures 5. In a scalene triangle, you'll see that they'll be marked as having different lengths for each side. But what do you do when you're asked to classify a triangle and it's on a grid like this and none of the sides line up against a line? It's pretty hard to see exactly how long each line is. So for that, we'll have to use the Pythagorean theorem. And the way I do that is I take it a side at a time and then I'm going to build a triangle. And the reason I build a triangle is because it's super easy to then count the horizontal distance and the vertical distance, and then I'll use the Pythagorean theorem to find the length of that missing side, and that will tell me how long side AC is. So let's practice a couple of these questions together, and then we can figure out if each of our triangles is going to be equilateral, isosceles, or scalene. Let's look at the first example. The directions say, use what you know about the sides of a triangle to determine if this triangle below is scalene, isosceles, or equilateral. And we have to show the work that leads to my answer. Well, it makes sense because I do have three sides, so I'll have to do the Pythagorean theorem maybe up to 3 times. And then I'll be able to tell you if the triangle is equilateral, isosceles, or scalene, and why. So first, let's look at this triangle. I can measure line BX, but I can't really measure these two segments without the help of my handy-dandy Pythagorean theorem. You'll see that there are two triangles that can be built, one triangle here and one triangle here. Let's use the Pythagorean theorem to measure the blue triangle first. I know that we'll start with the altitude squared plus the base squared is going to be that diagonal side squared. This triangle measures 3 by 6, so I'll be able to say the 3 squared plus 6 squared is x squared. This will be 9 plus 36 is x squared, so 45 is x squared. So x is going to equal the square root of 45, which I know is more or less close to 6.7. So I know that this right here measures 6.7. Let's try this green triangle. So I see that this is 3 by 6. Well, doing all this work all over again, that seems kind of useless. I can tell that the second triangle is also going to be 3 squared plus 6 squared, so it is the same math as above. I know that this will also be approximately 6.7. So this is 6.7 too. At least I know it's not scalene. For this last side, side XB, I can tell exactly how long XB is because it's vertical along the grid and it measures 6 units. So I had that line PX measures root 45, which is around 6.7. Line PB is the exact same, root 45. So I can tell you that this triangle is definitely isosceles because it has two equal sides. This is how we use the Pythagorean theorem to determine what type of triangle it is. Let's look at another example. In this triangle, let's use what you know to determine if it is scalene, isosceles, or equilateral. Well, we didn't get lucky on this triangle because AM, MD, and AD are neither of them along. So I'll have to do the Pythagorean theorem 3 times. Can you see my 3 triangles? Bam! There they are. Let's look at my first triangle. To determine the length of AM, which is the side along this blue triangle, I will have to use the Pythagorean theorem using the numbers 3 and 6. We'll do 3 squared plus 6 squared is x squared. This kind of looks like the one we just did, so I know that this becomes 45 is x squared. So x is the root of 45. Let's look at the green one. To determine the length of AD, I'm going to have to use the Pythagorean theorem on this green triangle. 1, 2, 3, 4, 5. Here's 5. 1, 2, 3, 4, 5, 7. So my math looks like 5 squared plus 7 squared equals x squared. 5 squared is 25 and 7 squared is 49. So we're looking at 74 is equal to x squared. So x is the root of 74, which is approximately 8.6. So line AD is around 8.6. I should have written here that line AM is around 6.7. Well, it's definitely not equilateral. Let's look at this last measurement. For this little bitty tiny triangle here, I know that this distance is 1 and this distance is 8. So my math for line MD is going to be 1 squared plus 8 squared to find x squared. 1 times 1 plus 8 times 8 is going to give me 65 as x squared. So x is the square root of 65, which means it is approximately 8.06. It's a little bit different than this one. This one's 8.6. This is going to be 8.06. Certainly not isosceles. So I know that this triangle is scalene because it has 3 different sides. Last example. Use what you know about the sides of a triangle to determine what type of triangle this is. Can you see my triangles? Can you see the triangle that'll be built right here? We'll do this one first. Then a triangle built right here. We'll do this one second. And then, yep, for BC, I won't need a triangle at all. I can just count the grid lines. All right, guys, it is your turn. Please go on to my MCPS classroom and use your learning of finding lengths to classify each triangle. Don't forget to type the work that leads into your answer. This is what each of your problems will look like when you are trying to classify triangles using the Pythagorean theorem to find the length of each side. Have a great day.